S. Chan presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Now, in order to calculate physical properties of the waves or the physical property of the interference pattern, such as refractive index, wavelength, from the interference pattern, how we can calculate? That can be done by using the Michelson interferometer. So, myself, Narendra Kaur, let us understand the Michelson interferometer, in which the interference pattern that is understood by using by calculating the physical properties of the wave. If you want to study this topic in detail, kindly refer this book by S. Chan Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. So the Michelson interferometer, basically this is an optical instrument which is used to measure out the physical properties of the light. So the physical property of the light, these are the such as wavelength, refractive index and the interference pattern. Such type of interferometer that is known as Michelson interferometer. Now that means if this is the light, we know that in the interference pattern we are using here the coherent sources. So the light is coming from here. So if there are the two light waves are there from the two sources, you can say that. So that means if this is a coherent lights over here, then there occur either constructive interference or destructive interference. Now for the constructive interference, at the resultant we are getting a single wave. Now what is the wavelength of this wave? And corresponding to this wavelength, what will be the frequency of this wave? And the refractive index of the medium, in the medium where the interference pattern is done. So all that things that can be understood by using a Michelson interferometer. So Michelson interferometer, now it is depends upon the based upon the idea of interference of the light or of the wave by the division of wavefront. So in this case, we understood over here the interference of light. That means when we know that the two light waves with a similar wavelength or the similar frequency, they are combined with each other, means they superimpose on each other. Then in the resultant, the amplitude of the wave that is get enhanced. So that is corresponding to constructive interference pattern. On in the second way, when the two similar wavelength waves with a similar wavelength, they superimpose on each other in the destructive manner, means when the maxima of one falls on minima of other. So that in that case, the resultant intensity that will cancel out. So that will lead to destructive interference. So that means in the resultant or in the interference pattern, we are getting the bright rings or we are getting the dark rings. So that will depend upon the condition of constructive interference or the condition of destructive interference. Now the Michelson interferometer, it is based upon the division of amplitude scheme. That means now we understood the interference that is of two types. Interference that can be done by the division of wavefront or that can be done by the division of amplitude. So interference in the Michelson interferometer, that is based upon the interference by division of amplitude. So now in order to understand the Michelson interferometer, so these are the measurements which can be done. First one, that is the width and the fine structure of spectral lines. Means the spectral lines which are get formed, so their width and their structure, fine structure, how the maximas and minimas, they are arranged with each other. That can be calculated over here. Second one, the length or displacement in terms of wavelength. That means the path difference between the maximas and the minimas, that can be calculated in this case. Third one, that is the refractive index of the material. That means the materials which is used or from where the light passes and the interference pattern is taken place. Whether the medium is used or the experiment is done in the air. So according to that, the refractive index of the material, that can be calculated. And third one, last one, the difference in the velocity of the light in the two directions. We know that when the light is propagating over here, the one part of the light is get reflected and one part is get transmitted. So in that case, what will be their velocity in the two direction, whether the velocity of the material velocity of the light, that will change, that will depend upon the direction or not. That is also can be understood by using the Michelson interferometer. So here we will prove that the velocity of light remains constant always. That is equals to C, which is equals to 3 into 10 raised to the power 8 meter per second. So firstly, some assumptions are made. According to that assumptions, it is done. Let us suppose the light goes on changing when there occur reflection or transmission. So that means when the direction is changing, the velocity goes on changing. So after that assumptions, we will comes to the pattern that the velocity of the light that is remains constant always, which is 3 into 10 raised to the power 8 meter per second. Now, what is the principle of Michelson interferometer? Now, Michelson interferometer, it is based upon the principle of interference of light. Interference of wave or the interference of light waves here. Some part of the light is get reflected, some part of the light is get transmitted through the mirrors. So, here the two mirrors are get used. Now, this is the light source over here. Again, from the light source S. Here from the light source S, we are getting the spherical wavefronts. So these spherical wavefronts that can be converted into parallel beam by using a lens over here or by using a glass plate. Now you can convert these spherical wavefront from this source into the parallel wavefronts by using a lens or by using a glass plate. Now when the lens is used, so the light coming from this source that can be converted into parallel beam. So here the parallel beams, the light will be getting from here. Then we are using here two plates. One is a plate G1 and second is a G2. So these two plates are again inclined at an angle 45 degree. The light will fall on this plate. Again, now at this point, some part of the light that will be reflected and some part of the light that will be refracted or transmitted over here. So one part of the light that will be reflected over here and one part of the light that will be refracted. Again, this will pass through from here. Here is a mirror A2. This is a fully silvered mirror is present over here. Now the second mirror that is also fully polished over here. That means the light from these two. Here the light is get reflected, again goes back. After that it will reflected back and passes through this glass plate, and here we will get the interference pattern. The microscope is used over here in order to get the interference pattern in this case. Again this light will passes through here, then reflected back from here. After passing through this, we will get here from the microscope the light from point mirror A1 and from the mirror A2. They both will superimpose on each other to get the interference pattern over here. So here, now the spherical wavefronts are converted into parallel wavefront by using a lens. Lens is used. These parallel wavefronts are falling on the glass plate G1 and there is a glass plate G2 is used over here. Now the reflected light directly go to the mirror A1. Now this will go to the mirror A1, then after the reflected back, it passes through this glass plate G, then comes over here. Now the transmitted light passes through this glass plate G, again it passes through this glass plate G, reflected back, then passes through glass, again this glass plate G2, then come back over here. So now why the glass plate G2 that is introduced over here? In order to overcome the path difference between these two rays. Here the one ray is a reflected beam and that is a transmitted beam over here. Now in order to overcome the path difference between reflected beam and the transmitted beam, because these two beams they will reunite over here and we will get interference pattern that can be seen by the microscope. So the microscope of the observer that are used in order to see the interference pattern. So the interference pattern, now we are getting here the interference pattern. So in the interference pattern, so that means now this is consisting of two highly polished plates which are acting as a mirror. So these are two, they will act as a mirror. So one surface of them that is highly polished. So why this is polished? So that the no light is transmitted from A1 and A2. When the reflected beam falls on the surface, completely or the whole of the light that will be reflected back. Again, when the transmitted light fall on the mirror A2, now its one surface is fully polished. So again, it will reflected back completely without any transmission. So that's why these two mirrors are taken as fully polished surface. Again, now this is known as a glass plate G1, and in order to compensate the path difference between these two rays, we are using a glass plate G2. So that's why this glass plate G2 is known as compensating plate, because this reflected beam travels twice over here. So it travels two times. While the transmitted rays, firstly it will travel once when the glass plate G2 is not present over here. So in order to overcome the path difference between these two rays, the glass plate G2 is used. Again, from these two plates, the light will reunite over here, and from the microscope we will get the interference pattern. So Michelson interferometer, that is use the principle of interference of light waves by the division of amplitude. That means the division of amplitude is used in this case. Now next is the two main requirements which are used for the interference pattern. So first one, we will use here the extended source of light, because when the point source is used, no fringes are get formed. So extended source of light is used. Now if there is already the point source is present instead of extended source of light, from the point source the light can be converted into extended source of light by using a lens. So that's why in front of this point source we are using a lens in order to convert this into a parallel beams. Means make this light as a extended source of light. So that is used over here. Next, the light must be monochromatic. We know that in order to get the proper position of fringes, brights and dark fringes which has get formed over here. So that means in order to get proper positions of maximas and minimas, monochromatic light that will be used. And the sources which are suitable for the Michelson interferometer, there are the mercury lamp, sodium lamp, they can be used in order to make. So that means the mercury lamp, here you can use this is a mercury lamp, arc lamp, that can be used in order to make the Michelson interferometer, or in order to get the proper interference pattern on the screen. So that can be formed. Now in some cases the small source bulbs that can be used in the labs also, but on the screen we are getting a diffuse interference pattern that can be obtained over here. So the main two requirements are that extended source of light is used and the light must be monochromatic. So these are the two main requirements for the Michelson interferometer. So now let us take a short break. So till now we have understood what is the Michelson interferometer, how the interference that can be understood by using a division of amplitude and the use of compensating plate G. After the break we will calculate the position of maximas and minimas.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Now before going to break, we studied the Michelson interferometer, how the position of bright and the dark fringes are calculated, and what is the use of compensating plate G in this case. Now the position of maximas and the minima that will be calculated over here. Now we know that in the Michelson interferometer, so the basic requirements are the use of extended source of light. Second one, the light must be monochromatic, and some light sources like sodium lamp or the mercury lamp that can be used. Now we will calculate the fringes. So firstly the circular fringes are get formed over here by using the monochromatic light. Monochromatic light means the light which is of single wavelength. Its wavelength is not varied. So that is used over here. Now the mirrors are placed in this case perpendicular to each other. So in order to calculate the position of fringes, whether the bright is formed or the dark fringes are get formed, we firstly calculate the path difference. So the path difference between the two rays, that can be calculated over here. Now for the maximas, we know that the path difference between two rays, that comes to be equals to 2d cos theta. So this is the path difference between reflected light and transmitted light when they are combining at the microscope. The path difference between the reflected light and transmitted light over here. Transmitted light when they reflected back from the mirror A1 and mirror A2, that is equals to 2d cos theta. So this is the path difference between two rays, because one ray is reflected and second one is refracted over here. So one ray, but after the reflection and transmission, both the rays are reflected back from the mirror A1 and mirror A2. Then they are combining at the microscope. So the path difference equals to 2d cos theta. Now we know that for the bright fringes, the condition for maxima, that will be the path difference, that will be equals to integral multiple of lambda over here. We know that the path difference, that will be integral multiple of lambda. What is m here? M is an integer, L is a wavelength, and d what is here? Theta is angle of incidence, and d is the distance between the two glass plates which are used over here. Now we know that if this is the path difference, then the phase difference, that can be given as, so phase difference, that is equals to 2 pi by lambda into path difference. Now the light is get reflected. So again there comes a phase difference between the two lights, because from the two mirrors A1 and A2, the light is reflected back. So with the path difference, there comes a phase difference between the two rays. Now the phase difference and path difference, they are related to each other by this formula. So phase difference, that is equals to 2 pi by lambda into path difference over here. So the phase difference, that will be calculated delta into 2 pi 2d sin cos theta by lambda. So that will be the path difference over phase difference. Now at the center, cos theta will be equals to 1. So this is equals to, we will get 2d equals to m lambda. So now with the destructive interference, now for the destructive interference, that means the condition of minima is there. So for the destructive interference, path difference between the two rays, that is equals to odd multiple of lambda, or you can say that integral multiple of lambda by 2, or you can write this as also 2 plus 1 lambda by 2. So that is a integral multiple of lambda by 2 or odd multiple of lambda. So that is the condition for destructive interference. So that means, so at this point, the destructive, that means the dark rings, that will be get formed over here, because the two waves, they are combined with each other with the phase difference. So a path difference is also present in the wave, phase difference is also present between the wave. So when they are combining with each other, now the two waves, the two rays, they are having the zero amplitude. After the combining to each other, we will get the ray with zero amplitude. Now why the amplitude is zero? Because these two rays which are superimposing on each other, they have the same amplitude, but the phase between them is 180 degree. So due to difference in the phase, that means the two waves which are combining with each other with amplitude plus A and minus A. So due to this, when the maxima of one falls on minima of other, then again minima of one falls on maxima of other. So in this condition, when you are adding up these two rays, at the end you will get a ray with zero amplitude. So this is the condition for dark over here. Now So the fringes which are get formed in this case, so we will get here the dark ring, bright, dark, bright and dark. So this kind of fringes that can be obtained in case of Michelson interferometer. So this kind of on the microscope we are getting such type of conditions are get formed. So that is totally opposite to the Newton ring experiment. In the Newton ring at the center we are getting the dark fringes, but here at the center, depending upon the conditions, whether the path difference is equals to integral multiple of lambda or it is equals to non-integral multiple of lambda. So depending upon that, at the center here the bright rings are get formed. So this is an interference pattern in the Michelson interferometer. That means at the center we are getting a bright ring. Because at center the path difference that is equals to m lambda, and where m that is changing from 0, 1, 2, 3 and so on. So that means here at the center when m is equals to 0, so that means the path difference that will be equal to 0. So if the path difference between the two rays is equals to 0, so then there occur constructive interference. So due to constructive interference at the center, the bright ring that is get formed over here. And at this point when the dark ring is get formed, the path difference that is equals to odd multiple of lambda. So now taking when m equals to 0, we will get here the path difference. For m equals to 0, the path difference that is equals to lambda by 2. So this is a condition for minima. So this is a dark ring that will be get formed. So this leads to the destructive interference. Now next is the localized fringes. Localized fringes. How the fringes can be localized? Now the one condition for the Michelson interferometer is that the mirror A1, now if this is a mirror A1 and that is a mirror A2, they must be placed perpendicular to each other. When they are not perpendicular to each other, what kind of fringes are get formed? That fringes are called localized fringes. Means when and also there are the two plates are placed. So these two plates, they must be parallel to each other. When they are not inclined at an angle 45 degree and these two mirrors, they are not inclined perpendicular to each other. Means if this condition is not there, here they are at 90 degree to each other and they are parallel to each other. Here the angle they are parallel to each other means theta for both the cases that is equals to here. This is also 45 degree. Again here the theta is also 45 degree. When this condition is not there, we are getting here the wedge shaped fringes are formed, means circular fringes are not formed. So we are getting here wedge shaped means distorted fringes are formed. So you can say that such type of fringes that can be formed over here. So these are the kind of wedge shaped fringes. When you see these fringes from quite far away, you are getting a straight kind of fringes are appeared over there. So such kind of fringes are known as localized fringes. That means when the mirrors are not placed exactly parallel to each other and their path difference is also that will be get disturbed, because when these are not placed parallel to each other, so the path difference between the rays which are reflected back and reunite in the microscope, that is disturbed. So in that case, the fringes are called semicircles, means semicircle fringes are formed, not the proper circular fringes are formed. So such kind of fringes are called wedge shaped fringes. So and the thickness of these fringes is also get varied, because as soon as you are going to change this angle theta, if this theta angle is goes on changing, the thickness of the fringes that will be also goes on changing, because their interference pattern is goes on changing. So such kind of fringes are called localized fringes. So that means the localized fringes are get formed in this case. Now, when you want to get the colored fringes, how you can use or you can get the colored fringes from Michelson Interferometer. So the colored fringes that can be obtained by using a visible light. That means that when the incident light is used as a visible light. When the incident light is used as a visible light, so in that case we are getting the colored fringes. So depending upon the wavelength of light and also distance of the light, where the place, at which place that is placed over here. So depending, now if there is a source and the light that can be converted into parallel beam. So depending upon this distance from the first plate, that is G1. So the color of the fringes that can be altered. At center, now we know that at center there occur constructive interference. So at center we are getting a white ring. Alternatively, depending upon the wavelength, the other circles they are of with different colors. So the color rings that can be, or the colored fringes that can be formed by using a visible light or by using a white light as a incident light. So that can be used formed in case of Michelson Interferometer. Means in the Michelson Interferometer you can change the shape of the fringes depending upon the position of the glass plate and the position of the two mirrors, or as well as by changing the incident light. So when the incident light is changed, the colored fringes are formed, and when you change this position of these two mirrors, you can get or you can alter the shape of fringes. So in the Michelson Interferometer, you can change the shape of the fringes by changing the position of mirrors, and also you can change the color of the fringes by changing the incident light. Thank you. This topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. Now if you like the video, kindly like, share and subscribe this video, and also you can press the bell icon for the future notification.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.